Welcome to this critical review of lightning protection systems. This presentation examines the science, standards, and safety considerations essential for effective lightning protection. Based on comprehensive research by E&S Grounding Solutions, we'll explore why traditional systems remain the gold standard, while non-conventional approaches have repeatedly failed to deliver on their promises. Lightning protection systems serve a vital purpose, providing a safe, low-impedance path for lightning energy to reach the Earth, thereby preventing damage to structures and their contents. Traditional Franklin-style systems, designed according to established standards like NFPA 780, offer proven protection against all four types of lightning damage. In contrast, non-conventional systems, including early streamer emission, charge transfer systems, and active voltage shield technologies, lack scientific evidence and have been rejected by standards organizations. Some have even proven dangerous. A key finding of this research is that lightning protection systems do not increase or decrease the probability of a lightning strike to a structure. Our recommendation is clear: use only traditional, standards-compliant lightning protection systems based on proven science. To understand lightning protection, we must first understand lightning itself. Lightning is a massive electrostatic discharge between electrically charged regions within clouds, or between a cloud and the Earth's surface. The formation process begins with charge separation within a thundercloud. Typically, the top of a thundercloud becomes positively charged, while the middle and lower portions become negatively charged. This charge separation creates an enormous electric field, both within the cloud and between the cloud and the ground. When the electric field becomes strong enough to overcome the insulating properties of air, a stepped leader is initiated, creating a channel of ionized air. Consider these remarkable facts. A single lightning strike can carry millions of volts. Temperatures can reach 50,000 degrees Fahrenheit, 5 times hotter than the surface of the sun. And lightning strikes the Earth approximately 100 times per second. The lightning strike process occurs in 4 distinct phases. First, the stepped leader. A channel of ionized air propagates downward from the cloud in a series of steps, each approximately 50 meters in length. Second, upward streamers. As the stepped leader approaches the ground, the electric field at ground level increases dramatically, causing upward propagating streamers from grounded objects. Third, the attachment process. When an upward streamer connects with the downward propagating stepped leader, a complete ionized channel forms between the cloud and the ground. Finally, the return stroke. This is the intensely luminous and powerful discharge that we see as lightning, propagating upward from the ground to the cloud. It's important to understand that the attachment process is probabilistic. The object that is struck is the one that launches the upward streamer that successfully connects with the stepped leader. Lightning protection systems do not attract lightning. Rather, they provide a safe path for the current. Lightning can cause damage through 4 distinct mechanisms. First, electromagnetic pulse damage. The most common type. Lightning creates a powerful electromagnetic pulse that can induce large transient voltages in conductive systems miles away from the strike point. Second, ground reference potential change. When lightning strikes the ground, the electrical potential can rise dramatically, causing current to flow between different grounding points. Third, strikes to power and data lines. These are actually more likely than direct strikes due to the extensive network of conductors. Such strikes send dangerous surges directly into facilities through electrical infrastructure. Fourth, physical or direct strike damage. While the least common, this is the most dramatic type, capable of causing fires, explosions, and structural damage. This is the primary focus of traditional protection systems: a comprehensive lightning protection. strategy must address all four damage mechanisms. The Franklin-style system creates a Faraday cage effect using three main components. First, air terminals. Pointed metal rods mounted at the highest points of a structure to intercept lightning strikes. Second, down conductors. Heavy-duty electrical conductors, typically made of copper or aluminum, that connect air terminals to the grounding system. Third, the grounding system. A network of buried conductors designed to dissipate lightning current safely into the earth. These systems are governed by established standards, including NFPA 780, the standard for the installation of lightning protection systems, and IEC 62305, protection against lightning. Most importantly, these systems have over 2 centuries of successful field experience demonstrating their effectiveness. In contrast to proven traditional systems, several non-conventional approaches have emerged over the years. Early streamer emission systems claim to attract lightning by extending upward streamers earlier than conventional terminals. However, these claims have failed due to environmental factors and are not supported by scientific evidence. Charge transfer systems and dissipation array systems claim to prevent strikes by dissipating electrical charge before lightning can form. This concept is scientifically implausible and has been rejected by the NFPA 4 times between 1989 and 2005. Active voltage shield systems claim to repel lightning using opposite polarity voltage. This approach is fundamentally flawed, and there are documented cases of deaths and injuries associated with these systems. The key finding is clear. Both approaches to control lightning strikes have failed. Attempts to attract lightning and attempts to prevent lightning demonstrate that mankind cannot reliably control the probability of lightning strikes. This slide emphasizes our critical conclusion. Both approaches to control lightning strikes have failed. Attempts to attract lightning through early streamer emission systems and attempts to prevent lightning through charge transfer and dissipation array systems have both proven unsuccessful. This demonstrates conclusively that mankind cannot reliably control the probability of lightning strikes. The science is clear. We cannot make lightning more or less likely to strike a particular location. What we can do is provide a safe path for the inevitable strike to follow, which is exactly what traditional Franklin-style systems accomplish. The scientific community has thoroughly evaluated non-conventional systems and found them wanting. In 1995, the National Fire Protection Research Foundation conducted a comprehensive review of early streamer emission technology, concluding that the claims for enhanced performance of SA air terminals are not supported by theory, by laboratory testing, or by field experience. In 2002, leading lightning experts Dr. Martin A. Human and Dr. Vladimir A. Rokov published a critical review stating that neither data nor theory supports claims that early streamer emission techniques are superior to conventional lightning protection systems. In 2005, a U.S. federal court ruled in Heery Brothers Lightning Protection Company versus NFPA that advertising claims made by an ESE manufacturer were literally false. And in 2012, the International Conference on Lightning Protection, the world's most prestigious scientific body on lightning, issued a statement strongly opposing SA systems, citing lack of scientific basis and potential dangers. Our conclusions are straightforward and evidence-based. Traditional lightning protection systems, designed according to established standards, provide effective protection against all 4 types of lightning damage. Non-conventional systems lack scientific evidence, have been rejected by standards organizations, and in some cases have been proven dangerous. Lightning protection systems do not increase or decrease the probability of a lightning strike to a structure. Our recommendations are equally clear. use only traditional, standards-compliant lightning protection systems, follow NFPA 780 and IEC 62305 guidelines for installation. Avoid non-conventional systems that lack scientific basis. And be aware that false security can lead to tragic consequences. This presentation is based on extensive research and peer-reviewed scientific literature. For more information about lightning protection systems and E&S grounding solutions services, please contact us at our Laguna Niguel, California office. Visit our website at www.sgrounding.com or email us at info@sgrounding.com. Thank you for your attention.